Okay, so here we have the graph of something, as you can see, although you can really see that it passes the vertical line test. It should be easy to see that any vertical line you draw will either intersect the graph once or not at all. So we have a graph of a function, but now we want to figure out what the domain and range are. Well, again, for the domain, so the x-axis is always the horizontal one. Let me just fill that in here. For the domain, you have to imagine taking the graph and pushing it onto the x-axis, kind of like squishing it onto the x-axis along these so-called vertical lines. But hopefully you can see how we're going to get everything from here to here. So it looks like we're going to get, so for the domain, it looks like we're going to get everything from -3 to 4. And for the range, it's actually very similar. The only difference, though, is that you're going to push onto the y-axis. So you can imagine doing this. Now here it's a little bit different because here we go. Now we're going to the left, and hopefully you can see you're going to get all this, which, well, so for the range, it looks like what we're going to get is, let's see, what did I get? -6 to, no, excuse me, -8 to 6. Actually, you know what? Let me erase a little bit here. So we get -8 to 6, as you can see. And in fact, that's what we get here. Good. So we have that example. Here's another one, same idea. Hopefully it's easy to see that if you were to draw any vertical line, right, you can see that every vertical line you draw will either not intersect the graph or intersect the graph at most once. So this is the graph of a function now. Let me just erase these. So now, let's find the domain. Well, it's the same idea as before. What do? We want to imagine taking the graph, imagine taking the graph and pushing it onto the x-axis. Excuse me, I was doing that wrong. Imagine taking the graph and pushing it onto the x-axis and see what we get. And from what it looks like, the domain here is going to be all this, which is the interval from 0 to 5. And for the range, it's similar. Again, the only difference here is that you're going to push it onto the y-axis, so you're going to have to move horizontally. But hopefully you can see from what I'm drawing here, it looks like you're going to get all this. So it looks like we're going to get -5 to 10, it looks like, if I read this correctly. Like so. So that's what our range is going to be for this one. And really, this is just what I was saying before. If you take the graph of any line that is not vertical, hopefully it's easy to see that it will pass the vertical line test, right? Hence, it will be the graph of a function. And also it turns out that the domain will be all real numbers, right? This notation here is the same notation for all real numbers. Now, unless the line is horizontal, then the range will also be all real numbers. So any non-vertical line will have domain and range. Any non-vertical line will have domain equal to all real numbers. And if the line is not horizontal, then the range will also be all real numbers. If the line, let me draw this quickly, but if the line was horizontal, like this, let's say, then the range is going to be a single number. So if this number passes through, let's say, I don't know, we'll call that number k, then the domain will be everything, but the range will be just the number k. Good. Remember, a vertical line is not the graph of a function. Okay. And here, this is just a graph of a function. That's good to know. It's the function y equals x cubed. Let me just point out, though, that the graph does actually keep on going. So its domain and its range turn out to be all real numbers. The function y equals x cubed. And another function that's good to know is the square root function. Notice here, hopefully you can see that the domain is all numbers greater than or equal to 0, mostly because you can take the square root of anything non-negative. And also the range is the same thing. So here the domain, let me write it out. The domain of this function, the square root, is all non-negative real numbers. And the range is also all non-negative real numbers as well. So it's just something I wanted to point out. Okay, now we can actually define a function using equations. In other words, we can actually define a function if we have an equation in the variables x and y. Essentially, the best way is to sketch the graph of the equation and just see, does that graph pass the vertical line test? If it does, then you have a function. Specifically, you have y equals f of x, as over here, where f is that function. So again, let me say that again. If you have an equation in x and y, the two variables x and y, if you sketch its graph and the graph passes the vertical line test, then you have a function. You have y as a function of x. I don't know if I said it before, but when we have y equals f of x, where f is the function, we also say y is a function of x. Really what's happening in the background is, with the equation, you can sketch its graph, and as I said before, from the graph you get a relation, namely the collection of all plotted points in the plane that are on the graph. Hence, you have a relation, just that relation will have infinitely many points. And you have a function exactly when the graph passes the vertical line test, and that occurs exactly when the relation is a function like we saw before. So that's what I was trying to say earlier. So as an example, if we go to this example here, well, remember, you can actually solve for y in terms of x from here, and that's what I do over here, and you end up getting y equals, where is it? You actually get y equals negative 6 plus 2x. Well, remember, the graph of that is a non-vertical line. I mean, really, from here, you should be able to see it's a non-vertical line. And so because of that, the graph passes the vertical line test, and so it's a function. Namely, we have y is a function of x, and so we have this. And so we have that. And again, this tells us how we get each output from each input. So for instance, if we take x to be 1 as our input, right, if I were to go back to, I guess almost like a correspondence diagram, 1 as our input, okay, then our corresponding output would be f of 1, which from here is just negative 4. Let me just make this circle a little bit better. And so, for instance, here we have, if you have 2, plug it into the equation, you get f of 2 is negative 2. In fact, if you were to graph it, every point on the graph would be of this form. You have an x, this is your y, and this tells you how to calculate your output, which is what y represents. As another example, we have this, 4x minus y equals 1. Well, again, this is the graph of this is a non-vertical line. How can we get that? Well, if we add y to each side, we get 4x is 1 plus y. And so we have 4x is 1 plus y. Subtracting 1, we get, over here, we get 4x minus 1 equals y. So we have y is 4x minus 1. So just like, so again, as I said before, y equals 4x minus 1. Well, that's a non-vertical line. So this does give us a function. Y is a function of x. Okay. We can actually take this a step further and consider any function of this form. If you have f of x equals a polynomial in x, then we have what's called a polynomial function. So again, a polynomial function is a function, f of x, defined by a polynomial as over here. And it turns out any polynomial function has domain equal to all real numbers. The range actually takes a little bit of work to figure out what it is. The range can vary, but the domain is always all real numbers.